Magic of the internet, or how to survive the digital age. Here is a simple visual of what the internet does. You start off in your home with your computer. Information is sent to the router. The router sends the information to the internet, which is the same thing as the cloud. The internet and the cloud are synonymous from your point of view. So when someone says the cloud, don't freak out. It's just like a device, a bunch of devices out there. And then at the other end, the data is sent to a specific device to do something with. That device can be an email server, it can be a web server, it can be a storage device, but all that is happening is information is being sent out to a specific location. You remember surface mail. What did you do in surface mail? You would write a letter, you would address it, you would give it to the postman would work their magic. How they did it, you didn't know, but it would end up at that addressee's location, at which time they would open it, take it out, and read it. That is exactly the way the internet works. Exactly. This is what the internet or the cloud does. It just sends data, addressed data. It has an address to know who this other guy is. Let's talk about what happens inside your computer to make this magic work. You have an application that needs internet access. In order to get the address, the application contacts the communication software and goes out to something called a domain name server and says, hey, I have this person. Give me its real internet address. A phone book. It's identical to a phone book. You all do remember phone books, right? The phone book, what you would do is you go into your phone book, find the person's name, and you get their phone number. The domain name server is identical. You give it a name, which can be an email address or a web server address. You know, the URL. It goes to the domain name server and says, what is this guy's actual street address? And gives it back to you. It packages up the data into packets to give to TCP/IP. Transmission Control Protocol is what it's called. This is the guy who sets up the virtual connection. He sends it out to the router. But actually what happens is a little bit different. TCP says, hey, internet, I need to talk to this address. Can you do it? He has no idea with anything else out there. And he gets a response back saying, yes, I can. Send me the data. And then TCP shoves the data down the line. He has no idea. As far as he's concerned, it's one connection. Now, remember back here when I showed you this one, this virtual, that it's setting up a connection, a pipe. It has no idea how it gets there. It doesn't care. All it knows is when you address your envelope, you put an address on it, you send it out, and you get something back. It does the same thing. It sets up a virtual. It looks like a solid pipeline, one connection. What really happens is they take the letter, give it to the post office. The post office cuts it up into little bitty pieces and sends each one of those pieces all over the world. And then eventually they get to Los Angeles where they glue it all back together and give it to you. As far as you're concerned, it's one piece. And that is exactly how it works. Below TCP is something else, and that's where the magic takes place. How does TCP find out its destination? TCP is the one who goes to the domain name server. You feed it, you say, hey, TCP, I want to send this information. This is the application talking. Now, the application is making calls to TCP, which is a separate entity on the machine. It's actual code that is made available to developers, and it says, here's the address I want to send it to, and this is how much information I want to send. So TCP says, okay, contacts the domain name server and says, give me IP address. That's what it's called. It's that funny, it's 3 numbers, 3.3.3.1.111.111.111.111. That's an IP address. Here is an email address, john@buno.us. His IP address is blip. TCP says fine, gets it, and then domain name server, and this is what a thing that most people don't understand. If the domain name server does not have an entry, it's not going to give you an IP address back. That's why, the domain name server is not a single entity. It is a number of them. They keep each other informed of what's going on. So as long as you are registered, and that's what your ISP provider does, is make sure that your name is associated, let's say, with Cox. When you get a Cox account, your email address is registered with Cox so that all incoming traffic to you goes to the Cox server to come down to you. So that's what the domain name server, that's step one. Crucial step. And that's why sometimes you come back and it says unknown user. That means that that user doesn't exist. They don't know who he is. Your application browser asks the operating system to make a connection. It's calling up TCP. It gives it the IP address and the destination port. Now, it gets that from the domain name server also. There are specific ports. Now, these are virtual ports. It's like a socket, and there are certain sockets that are designed for certain types of information. Port 443 is specifically designed for HTTPS, your web server security. All information goes to that port because it's designed to handle that. Now, the fun starts. TCP adds the source and destination ports, adds sequence numbers as it's cutting up the information. Each packet of information has the originator IP address, which is not the one of your device. Okay, it's the one of your router, because a router is what everybody knows about. The sequence of the packet numbers, how many packets and which packet it is, it adds a reliability, a synchronization, and acknowledgement, so that when a packet of information is sent, it knows that it came back, but there's no IP address inside TCP, because TCP sends it down to IP, the Internet Protocol. Now, IP does is it adds the destination IP, adds time to live. Each packet has so much time in order to get to its destination. Now it becomes a complete packet. Now what happens is IP just starts sending packets out. And it says, hey, can you accept this packet? Talks to another computer. Can you accept it? Yeah, I know how to get to that address. Okay, I'll take it. And while it's doing that, when it goes to another computer, it says, hey, can you send this one? Yeah, I can send that one. And all these packets go out to possibly completely different computers, depending on how many that network server can talk to. How many lines does it have? And each packet goes out, and the IP at each of the different intermediate points is the same thing. Hey, can you accept this IP address? Yes or no? If it says yes, give it to me. If it says no, tries to find somebody else. This is worldwide. So the IP packets that you are sending out from that one application can travel all over the world. And sometimes what happens is a packet will get someplace and it comes back and says, no, I can't reach that guy. No, I can't reach that guy. And the time to live comes up in the packet. Well, at the destination, IP is taking all these packets and shoving it up to TCP. And TCP puts it back together. And all of a sudden TCP says, I'm missing a packet. I cannot successfully complete my mission of putting this back together. So it sends a non-acknowledgement back to your TCP. It says failed transmission. Or in most cases, the web page you're trying to load just doesn't load. It just sits and spins and it never stops. That's why, because somewhere along the line, something happened where a packet got mangled. If the packet comes in, there's a checksum number that goes with it as to that number must match the checksum that runs to make sure the data is correct. So it runs this algorithm and says, oh, hold it, something's wrong. The checksums don't match. Sends a non-act back saying, we got a problem with this packet, resend that packet. And all this is going on at the speed of light. When you send a large file, we're talking about millions of packets going out, because each packet, they're relatively small, so they can go quick. Let's go back to the post office. You are sitting at your desk at your home. You are in your office. You address your return address. Do you use the address of your room or the address of the house? Right. That's what your router does. So you write the letter, you put it in the post office. Postman, who's also TCP, picks up the letter, looks at the to address. It says, all right, how do I get the letter with this address to that destination? Well, it goes and looks up in a directory, domain name server, saying, for this address, I need to send it to this other post office who will take care of delivering it. What's happening at the IP level is that IP is taking that letter, cutting it up into hundreds of little tiny pieces because it can go a lot faster. Each of them is addressed to anybody that can get to it, whoever they're connected to. And each of them in turn say, how do I get this to that destination? And they keep going until they all come back together where you're mailing it to. And the postman there starts going through and making sure that the size is correct. That's a checksum. The sequence, because they've all been numbered, puts them together, runs another checksum to see if it's correct, or if it determines that it's missing a packet, it goes back to who it believes is the originator, who is the originator, that post office, that says, I need to add to the TCP to you. It says, I need this packet. It didn't come through. Send it again. What happens on Wi-Fi versus Ethernet? We were talking about NAT. NAT does is it makes the internet, there's one address it's talking to, when in fact, there's all kinds of devices back there. And this is done by the NAT. Network Address Translation. The network is your home or office. The address is the IP address, and the translation is changing one address to another. So what it does is it takes your address, it gets to the NAT, it translates that into the address of your router, and that's what goes out. And then when it comes back in, it knows that, hey, this information is destined for this IP address. So it sends it back to you. Now, stop and think about that for a second. All that's going on, and it rarely does not work. So it's taking your information, keeping track of it, of the IP addresses, who it's for, type of information, puts it in there, and just think about all the things that are going on. And it works. I mean, to me, it's absolutely amazing. And when you get home, start counting the number of devices in your home that actually connect to the internet. It's like a hotel. You send mail to the hotel, and the hotel looks up where you are and sends it to you. So the address you give is the hotel's address. Stuff is delivered. They look up your name to find out what room you're in and deliver it to your room. That's exactly what NAT does. So the internet is not that foreign, based upon how we live our lives. I'll put it all together. DNS finds the IP address. The application gives the IP to the OS. And inside the OS, the operating system, TCP adds reliability, IP adds addressing. The router may rewrite it, and that's NAT, it generally does. And the packets travel across the internet. TCP says, hey, Joe, I got stuff to give you. Joe answers back, okay, I'm ready. TCP says, okay, I'm sending down to IP to make the delivery. IP says, ah, goes berserk. He says, how do I get all this stuff out? Starts throwing stuff all over the place to try and get it. Now, it is possible to all go over one connection. But if it can't, IP just starts throwing it out. And when it gets to Joe at the other end, Joe's IP starts putting it back together, hands it up to TCP. And as far as TCP is concerned, it's one connection. It has no idea what's going on at lower levels. And IP doesn't know nor care about how it gets there. It can go out over radio, it can go out over wire, it can go by donkey. Nobody knows. He doesn't care. All he knows is I'm sending it out to somebody who says they can handle it. Ethernet, Wi-Fi uses radio waves, still carries IP packet. So you can put IP packets over the air. Ethernet uses cable, hard cable, but it's a special type of cable and it goes much, much faster than radio. Is radio catching up? Well, yeah, but cable is still getting faster. I mean, cable using fiber optic, we're talking about millions of megabits per second. Wi-Fi, we're still talking about gigabytes versus terabytes. I'm going to talk about real quick VPNs at this point. Virtual private network. The VPN's primary job is to protect data so it cannot be broken into until it gets to the VPN server that sends it out. So going from your home to the server and to a possible ultimate destination, it's locked. It also disguises your location. It can fool the network, because IP carries a location with it, into thinking you're someplace you're not. Now, why would people want to use this? Primarily Netflix. So you can go like to Great Britain and watch the Netflix in Great Britain that carries different content than Netflix in the United States. Or what I did when we were in Egypt is, instead of getting the Egyptian Amazon, I wanted the US Amazon. I had to go through a VPN. That's what the VPN does. That's all that it does. It protects your data for public networks. If you're in your own home, unless you're doing banking on a public network, you don't have to worry about it. Because once the data leaves your home, it's secured. If you're on a public unsecured network, like let's say you're in Starbucks and you want to check your bank account, you better use a VPN, because your passwords and logins can be easily captured on another device. VPNs are very easy to install. It's a little switch. After you install it, the switch says VPN on, VPN off. When you go to turn it on, it'll ask you, what location do you want to use? And most of them come back and say, hey, this is the best connection to use. What the VPN does is, the software on your phone, it contacts the VPN server and sends the data encrypted to it. And then it sends it out over TCP. But the data is completely encrypted. And then once it gets to the final VPN server, it decrypts it and sends it out over traditional line. Now we're going to talk about a website address, the URL. The DNS is activated. The OS says, hey, DNS, this is the URL, give me its IP address, and socket. The browser then connects to a web server, which is that IP address. The server sends back a web page, and your browser displays it. Basically, it's setting up a virtual connection as if you directly connected to that web server. You send it a request, it sends you back information. You send it the URL, it brings you back the page associated with that URL. Now, when you get a 404, that means I sent it for a specific page. The web browser says, hold it. That page does not exist. 404 error. That's not an internet. That is a web browser error saying the page you are requesting does not in fact exist. If it's a transmission error, what you'll see is spinning wheel of nothing coming back because somewhere along the line, the information got lost. Something most people don't understand is that the web server is strictly forbidden from accessing any information on your computer except for cookies that's stored with the web page. That is how it keeps information on you, like your name, last time you visited. That's what cookies do. There's another type of cookies that are used for advertisement to keep track of what you look at, what your history. If you're asked, will you accept cookies? Go in and take a look at what it's saving. What is a browser? Well, Chrome, Edge, Safari, Firefox, Chat Atlas, they're all browsers. What it does is it sends requests to servers. You give it what you want as a URL, Universal Resource Locator. It receives HTML files and then it displays it. Video is a special case. What you see as a video is not brought down to your computer. It stays on the server and is played from the server. Because if some of these videos, if you were trying to download a full-length movie, it would be hours. But the data to display it is very small. So that's why you can have almost instantaneous watching on YouTube because it's not downloading the entire video. It's just downloading the data to display it. Images, on the other hand, generally speaking, it will download the images, but not always. Sometimes it'll display it on the server. And you can tell the difference is if you click on an image and it delays in being displayed, that means it's downloading. Audio recordings generally will stay on the server, but it depends on how big they are. What happens when you click a link? The browser sends an HTTP request, server processes the request, server sends back a response. The response is in a markup language called HTML. It's pure text with images. The browser displays the new page, interprets the HTML to display it. It's just like what you're doing is you input the first URL to get you that page. The hyperlinks already have it in there and it activates it. That's all that's happening. And it's kind of a marvel. Now let's talk about what a web server is. A web server is a computer. What type of computer? Yes. You can use an Intel machine, you can use a Mac, you can use any computer out there can be made into a web server. And what this server does is it stores files and files and files and files of text material and images that are the web pages you see. So all that is being transmitted when you send your URL out, what comes back to you is text and the images. Most of them are highly compressed to make them small. Standard port is 80 for HTTP or HTTPS is port 443. Now, if you get a port error, that means that somewhere along the line, they have the wrong port. Like if you try and access HTTPS on port 80, you'll get a port error and the other way around. So, but when it comes back to you, your web browser takes that text material, just ordinary text, and displays it the way the person wanted. And that's called HTML. It interprets the HTML into the letters, sizes, colors, all that. That's not sent as a page. It's in its text material, which is the beauty of it. It's called page markup language. Hypertext page markup language, HTML. Okay. And hypertext, you know when you see the text with the blue line, that you can click on it? That's hyperlinks. What that does is it has an address in it. When you click on that, the whole thing starts over again. It goes and gets a specific page. Now, let's demystify the cloud. Everyone says, I don't understand the cloud. You don't have to understand it. It's not floating in the sky. It just means the cloud refers to someone else's computer. That's all that it is. It's somebody else's computer that's doing something that you want to have done. It could be an email server to handle email. It could be a web server to handle websites. It could be a storage facility. It could handle an application that is too resource intensive to be on your local computer. It's just another computer out there. Where? Who cares? You don't need to know its location. All you need to know is its service. And that's the beauty of the cloud. It's taken out the you having to figure out where to go. It just does it for you. Part of the danger is it, depending upon the sensitivity of your data, you may want to know. As you have seen, the internet is a magical place. But while the technology may seem overwhelming, when you break it down, it's not that complicated. I hope you enjoyed this presentation and will like and subscribe to this channel so we can continue to make these.